Recoverable errors with result. Most errors aren't serious enough to require the program to stop entirely. Sometimes, when a function fails, it's for a reason that you can easily interpret and respond to. For example, if you try to open a file and that operation fails because the file doesn't exist, you might want to create the file instead of terminating the process. Recall from handling potential failure with the result type in Chapter 2 that the result enum is defined as having two variants, OK and OK T, E. The T and E are generic type parameters. We'll discuss generics in more detail in Chapter 10. What you need to know right now is that T represents the type of the value that will be returned in a success case with the OK variant, and E represents the type of the error that will be returned in a failure case with the variant. Because result has these generic type parameters, we can use the result type and the functions that the standard library has defined on it in many different situations where the successful value and error value we want to return may differ. Let's call a function that returns a result because the function could fail. In listing 9.3, we try to open a file. Use standard fs file. Let f equal file : open hello.txt. How do we know file : open returns a result? We could look at the standard library API documentation, or we could ask the compiler. If we give f a type annotation that we know is not the return type of the function, and then try to compile the code, the compiler will tell us that the types don't match. The error message will then tell us what the type of f is. Let's try it. We know that the return type of file open isn't of type U32, so let's change the letF statement to letF of type U32 equal file open hello.txt. Attempting to compile now gives us the following output: mismatched types. Expected U32, found enum. Standard result. Note, expected type U32, found type, standard result, standard fs file, standard IO error. This tells us the return type of the file open function is a result TE. The generic parameter T has been filled in here with the type of the success value, standard fs file, which is a file handle. The type of E used in the error value is standard IO error. This return type means the call to file open might succeed and return a file handle that we can read from or write to. The function call also might fail. For example, the file might not exist, or we might not have permission to access the file. The file open function needs to have a way to tell us whether it succeeded or failed, and at the same time give us either the file handle or error information. This information is exactly what the result enum conveys. In the case where a file open succeeds, the value in the variable f will be an instance of OK that contains a file handle. In the case where it fails, the value of f will be an instance of that contains more information about the kind of error that happened. We need to add to the code in listing 9.3 to take different actions depending on the value file open returns. We need to add to the code in listing 9.3 to take different actions depending on the value file open returns. Listing 9.4 shows one way to handle the result using a basic tool, the match expression, from Chapter 6. let f equal file open hello.txt. Then shadow f with let f equal match f. OK, file, return file. Error, return panic, problem opening the file, debug format error. Note that, like the option enum, the result enum and its variants have been brought into scope by the prelude, so we don't need to specify result colons before the OK and variants in the match arms. Here we will tell Rust that when the result is OK, return the inner file value out of the OK variant. And we then assign that file handle value to the variable f. After the match, we can use the file handle for reading or writing. The other arm of the match handles the case where we get an value from file open. In this example, we've chosen to call the panic macro. If there's no file named hello.txt in our current directory, and we run this code, we'll see the following output from the panic macro. Thread main panicked at problem opening the file error. Some more stuff. Oh, here we are. REPR colon. I don't know if that's OS. I guess it is. Code 2 message no such file or directory. As usual, the output tells us exactly what has gone wrong. Matching on different errors. The code in listing 9.4 will panic no matter why file open failed. What we want to do instead is take different actions for different failure reasons. If file open failed because the file doesn't exist, we want to create the file and return the handle to the new file. If file open failed for any other reason, for example, because we didn't have permission to open the file, we still want the code to panic in the same way as it did in listing 9.4. Look at listing 9.5, which adds an inner match expression. So we're using standard fs file and use standard IO error kind. Let f equal file open hello.txt. Shadow it with let f equal match f. OK, file, return file. Error, return match error kind. Error kind not found, return match file create hello.txt. OK, fc, return fc. Return panic. Problem creating the file, debug e. End that match statement, match expression. So now we're back in match error kind, and if error kind is other error, return panic, problem opening the file, debug other error. The type of the value that file open returns inside the variant is IO error, which is a struct provided by the standard library. This struct has a method kind that we can call to get an IO error kind value. The enum IO error kind is provided by the standard library and has variants representing the different kinds of errors that might result from an IO operation. The variant we want to use is error kind not found, which indicates the file we're trying to open doesn't exist yet. So we match on F. But we also have an inner match on error kind. The condition we want to check in the inner match is whether the value returned by error kind is the not found variant of the error kind enum. If it is, we try to create the file with file create. But because file create could also fail, we need a second arm in the inner match expression. When the file can't be created, a different error message is printed. The second arm of the outer match stays the same, so the program panics on any error besides the missing file error. That's a lot of match. The match expression is very useful, but also very much a primitive. In Chapter 13, you will learn about closures. The result TE type has many methods that accept a closure and are implemented using match expressions. Using those methods will make your code more concise. A more seasoned Rustacean might write this code instead of listing 9.5. Let F equal file open hello.txt dot unwrap or else closure on error if error kind equals error kind not found file create hello.txt dot unwrap or else closure on error panic problem creating the file debug error else panic problem opening the file debug error. Although this code has the same behavior as listing 9.5, it doesn't contain any match expressions, and it's cleaner to read. Come back to this example after you've read Chapter 13 and look up the unwrap or else method in the standard library documentation. Many more of these methods can clean up huge nested match expressions when you're dealing with errors. Shortcuts for panic on error, unwrap, and expect. Using match works well enough, but it can be a bit verbose and doesn't always communicate intent well. The result TE type has many helper methods defined on it to do various tasks. One of those methods, called unwrap, is a shorthand method that is implemented just like the match expression we wrote in listing 9.4. If the result value is the OK variant, unwrap will return the value inside the OK. If the result is the variant, unwrap will call the panic macro for us. Here's an example of unwrap in action. Let F equal file open hello.txt dot unwrap. If we run this code without a hello.txt file, we will see an error message from the panic call that the unwrap method makes. Thread main panicked at called result unwrap on an value, error, ripper os code to message no such file or directory. Another method, expect, which is similar to unwrap, lets us also choose the panic error message. Using expect instead of unwrap and providing good error messages can convey your intent and make tracking down the source of a panic easier. The syntax of expect looks like this. Let F equal file open hello text hello.expect. Failed to open hello text. We use expect in the same way as unwrap, to return the file handle or to call the panic macro. The error message used by expect in its call to panic will be the parameter that we pass to expect, rather than the default panic message that unwrap uses. Let me read that again. The error message used by expect in its call to panic will be the parameter that we pass to expect, rather than the default panic message that unwrap uses. Here's what it looks like. Thread main panicked at failed to open hello.txt. Error, wrapper.os code 2 message, no such file or directory. Because this error message starts with the text we specified, failed to open hello.txt, it will be easier to find where in the code this error message is coming from. If we use unwrap in multiple places, it can take more time to figure out exactly which unwrap is causing the panic, because all unwrap calls that panic print the same message. Propagating errors. When you're writing a function whose implementation calls something that might fail, instead of handling the error within this function, you can return the error to the calling code so that it can decide what to do. This is known as propagating the error, and it gives more control to the calling code where there might be more information or logic that dictates how the error should be handled than what you have available in the context of your code. Listing 9.6 shows a function that reads a username from a file. If the file doesn't exist, or if it can't be read, this function will return those errors to the code that called this function. Using standard I/O, we're using standard I/O read, use standardfs file. Function, read username from file, return result, string, and the E-type is IO error. Let f equal file open hello text. Let mutable f equal match f. Okay, file, return file. E, return e. Let mute s equal string new. Match f.read to string, reference to mute s. Okay, wildcard, return okay s. E, return e. A function that returns errors to the calling code using match. This function can be written in a much shorter way, but we're going to start by doing a lot of it manually in order to explore error handling. At the end, we'll show the shorter way. Let's look at the return type of the function first. Result, string IO error. This means the function is returning a value of the type result TE, where the generic parameter t has been filled in with the concrete type string, and the generic type e has been filled in with the concrete type IO error. If this function succeeds without any problems, the code that calls this function will receive an OK value that holds a string, the username that this function read from the file. If this function encounters any problems, the code that calls this function will receive an value that holds an instance of IO error that contains more information about what the problems were. We chose IO error as the return type of this function because that happens to be the type of the error value returned from both of the operations we're calling in this function's body that might fail: the file open function and the read to string method. The body of the function starts by calling the file open function. Then we handle the result value returned with a match similar to the match in listing 4.9, only instead of calling panic in the error case, we return early from this function and pass the error value from file open back to the calling code as this function's error value. If file open succeeds, we store the file handle in the variable f and continue. Then we create a new string in variable s. Then we create a new string in variable s and call the read to string method on the file handle in f to read the contents of the file into s. The read to string method also returns a result because it might fail even though file open succeeded. So we need another match to handle that result. If read to string succeeds, then our function has succeeded and we return the username from the file that's now in S wrapped in an OK. If read to string fails, we return the error value in the same way that we returned the error value in the match that handled the return value of file open. Let me read that again. If read to string fails, we return the error value in the same way that we returned the error value in the match that handled the return value of file open. But we don't need to explicitly say return because this is the last expression in the function. The code that calls this code will then handle getting either an OK value that contains a username or an error value that contains an IO error. We don't know what the calling code will do with those values. We don't know what the calling code will do with those values. If the calling code gets an error value, it could call panic and crash the program. It could use a default username, or it could look up the username from somewhere other than a file, for example. We don't have enough information on what the calling code is actually trying to do. So we propagate all the success or error information upward for it to handle appropriately. This pattern of propagating errors is so common in Rust that Rust provides the question mark operator to make this easier. A shortcut for propagating errors, the question mark operator. Listing 9.7 shows an implementation of read username from file that has the same functionality as it had in listing 9.6, but this implementation uses the question mark operator. Function, read username from file, return result, string IO error. Let mutef equal file open hello.txt question mark. Let mutS equal string new. F dot read to string read to string reference to mutS question mark. Okay, S. The question mark placed after a result value is defined to work in almost the same way as the match expressions we defined to handle the result values in listing 9.6 revolt. If the value of the result is an OK, the value inside the OK will get returned from this expression, and the program will continue. If the value is an error, the error will be returned from the whole function as if we had used the return keyword So the error value gets propagated to the calling code. There is a difference between what the match expression from listing 9.6 and the propagator operator do. Error values that have the question mark operator, can I call it propagator? A shortcut for propagating errors, the question mark operator. The propagator cannot, well, I may. Can I? I don't know. All right. So here's the difference. Error values that have the operator called on them go through the from function defined in the from trait in the standard library, which is used to convert errors from one type into another. When the operator calls the from function, the error type received is converted into the error type defined in the return type of the current function. This is useful when a function returns one error type to represent all the ways a function might fail, even if parts might fail for many different reasons. As long as each error type implements the from function to define how to convert itself to the returned error type, the operator takes care of the conversion automatically. Okay, I'm going to stop doing that. I'm annoying myself too. In the context of listing 9.7, the propagator at the end of the file open call will return the value inside an OK to the variable f. If an error occurs, the propagator, which is the question mark operator, will return early out of the whole function and give any error value to the calling code. The same thing applies to the question mark at the end of the read to string call. The question mark operator eliminates a lot of boilerplate and makes this function's implementation simpler. We could even shorten this code further by chaining method calls immediately after the question mark, as shown in listing 9.8. Function read username from file, return result string IO error. Let mutess equal string new. File open hello text dot read to string. Reference to mutess. Okay, S. We've moved the creation of the new string in S to the beginning of the function. That part hasn't changed. Instead of creating a variable f, we have chained the call to read to string directly onto the result of file open hello text question mark. We still have a question mark at the end of the read to string call, and we still return an OK value containing the username in S when both file open and read to string succeed, rather than returning errors. The functionality is again the same as in listing 9.6 and listing 9.7. This is just a different, more ergonomic way to write it. Speaking of different ways to write this function, listing 9.9 shows that there's a way to make this even shorter. Function read username from file, return result string IO error, fs read to string hello text. Using fs read to string instead of opening and then reading the file. Reading a file into a string is a fairly common operation, so Rust provides the convenient fs read to string function that opens the file, creates a new string, reads the contents of the file, puts the contents into that string, and returns it. Of course, using fs read to string doesn't give us the opportunity to explain all the error handling, so we did it the long way first. The question mark operator can only be used in functions that return result. The question mark operator can only be used in functions that have a return type of result because it is defined to work in the same way as the match expression we defined in listing 9.6. The part of the match that requires a return type of result is return e. So the return type of the function must be a result to be compatible with this return. Let's look at what happens if we use the question mark operator in the main function which you will recall has a return type of unit, the empty tuple signifier. In the main function, let f equal file open hello text. When we compile this code, we get the following error message. The question mark operator can only be used in a function that returns result or option or another type that implements standard standard ops try. So here we have cannot use the question mark operator in a function that returns the unit signifier, the empty tuple. Help! The trait standard ops try is not implemented for your main function dum-dum. Sorry. You're not dumb. Note, required by standard ops try from error. This error points out that we're only allowed to use the question mark operator in a function that returns result te. When you are writing code in a function that doesn't return result te, and you want to use question mark when you call other functions that return result te, you have two choices to fix this problem. One technique is to change the return type of your function to be, they're going to do that. They're going to do that to main. They told me they'd never do that. Okay. No, okay. What they told me was that they would never put anything in. They would never, main should never have a parameter. That's what they told me. I bet that's a lie as well. But main gets his little bubble. Nobody puts anything in main's little bubble. Where was I? Yeah, okay. Two choices. One is you can change the return type of your function to be result te if you don't have any restrictions preventing that. The other technique is to use a match or one of the result te methods to handle the result te in whatever way is appropriate. The main function is special, and there are restrictions on what its return type must be. One valid return type for main is the unit signifier, the empty tuple. I believe that's called unit. And conveniently, another valid return type is result te, as shown here. Well, that's handy. Let main return result unit or box dynamic error. Let f equal file open hello text. Okay, unit. The boxed-in error type is called a trait object, and we'll talk about it in using trait objects that allow for values of different types, the section in chapter 17. For now, you can read boxed-in error to mean any kind of error. Using question mark in a main function with this return type is allowed. Now that we've discussed the details of calling panic or returning result, let's return to the topic of how to decide which is appropriate in which cases.